Okay, so welcome back to the deep dive.
Glad to be here.
Today, we're diving really deep into something incredibly small, carbon nanotubes.
Tiny stuff, huge impact, right? Especially for EVs, electric vehicles. That's our focus.
Exactly. We're looking at how they're changing the game, particularly in batteries.
And for this, we've really dug into some specific materials. We've got bits from a Mordor intelligence report on the carbon nanotube market itself.
Right? And also an article, Carbon and Nanotubes, EV Battery Revolution. Gives a good picture.
Definitely. So our goal here really is to unpack what these things do.
Yeah, show you why they're so critical for making EVs better and, importantly, why the industry's investing, well, quite heavily in them.
Mm-hmm. And these sources, they really highlight a persistent issue for EV makers, battery electrodes.
The design, the materials, it's always a challenge.
It is, and that's where carbon nanotubes, or CNTs, are really starting to stand out as a solution.
Okay, so let's get into the specifics. What makes them so special in a battery?
Well, the reports point to their role as conductive additives in lithium-ion batteries. They have amazing properties.
Like what?
Like superior thermal conductivity, they handle heat really well. Plus resistance to other stuff, electromagnetic waves, even dust, static.
Wow, okay. So pretty robust little things.
Very. And the data we saw is, well, quite compelling, adding CNTs as conductive materials.
Yeah.
The sources say they can boost conductivity by over 10% compared to the usual stuff, like carbon black.
Over 10%. That sounds significant.
It is, but that's not all. It gets better.
Yeah.
Using CNTs also means you can cut down on the total amount of other additives needed
By how much?
by up to 30%, according to the sources.
30% less filler, basically.
Right. Which means you can pack in more of the active material.
Ah, the stuff that actually holds the charge, like the cathode material.
Precisely. More active material in the same space or the same weight.
Okay, so that translates directly to better batteries, right? Denser batteries.
Could be. Or lighter packs for the same range. Or, just more range in the same size pack.
Which, for anyone driving an EV, tackles big things like range anxiety. Or it just allows for maybe sleeker car designs if the battery's smaller.
Absolutely. And it's not just about the electrodes, interestingly.
What else?
The sources mention some car makers, like Hyundai, are looking at using CNTs as actual heaters.
Heaters. Wait, using the battery material itself to heat the car? How?
It's about their heat transfer speed. It's apparently incredibly fast.
Faster than normal heaters.
The claim is 3 times faster heating speed compared to conventional PTC heaters.
3 times faster. So on a cold day, the car warms up much quicker.
That's the idea. And potentially using less energy to do it.
Ah, so less drain on the main battery just for heating.
Exactly. Which means more of that battery power goes towards driving range. That's a big plus, especially in colder places.
That's kind of wild. Using the same material to boost battery performance and heat the cabin efficiently.
It shows the versatility, and it's clearly moving beyond just theory.
Yeah, the investment side seems to confirm that. The sources mention some serious money flowing in.
Oh, definitely. Major car companies, big chemical firms, they're putting substantial capital into CNT tech specifically for EVs.
We saw names like MG Motor India planning, what was it, $100 million investment back in early 2023.
Geared towards this kind of capacity. And Mahindra too. A huge $1.2 billion plan for an EV facility using advanced materials like these.
Right. And the suppliers are stepping up too.
Yes, like LG Chem. They've already expanded their CNT production, anticipating all this demand from the EV sector.
These aren't small bets. It really signals that the industry sees CNTs as foundational, transformative even.
It really does. It shows these microscopic tubes are becoming essential building blocks.
Okay, so let's quickly recap the key points from this deep dive.
Sure. Carbon nanotubes are becoming really important additives in EV batteries.
Right, boosting conductivity, letting manufacturers pack more energy in, potentially extending range.
And improving overall efficiency. Plus, there's this whole other angle with heating applications being explored.
Yeah, that efficient heating idea is fascinating.
And the massive investment from big players across automotive and chemicals really underlines it.
It confirms CNTs aren't just some niche material. They're seen as a core part of the future of EV manufacturing.
Absolutely. It's happening now.
So, a final thought to leave you with.
When you think about how these, incredibly tiny structures can make such big improvements in something like a car battery, or even how it heats up.
Yeah.
It makes you wonder, doesn't it? What other invisible materials, what other bits of materials science are quietly being developed right now?
Hmm. Things that could be unlocking the next big leap in everyday technology, maybe in places we don't even expect.
Exactly. What other hidden innovations, tiny materials, might be shaping the tech you'll be using tomorrow? Something to think about.